Hi, welcome to Quantum Academy for Physics. This is our 6th class. I'm sorry that I didn't upload any video since 2 months. And I just want to go as quick as possible. I just want to complete differential equations. In last class, we have learned to find particular integral for a higher order non-homogeneous differential equations. We have learnt few methods. These are the three methods we have learnt in our last class for a non-homogeneous differential equation of the form f of d into y is equal to f of x, and this f of x must be not equal to 0. And in our last class we have learnt that if f of x equals to e power ax, what is the method to use for this type of equations to find your solutions. And if f of x equals to sin ax or cos ax, and third one is f of x equals to e power ax into f of x. This f of x is equal to sin x cos x or polynomial in x. And in today's class we will find few more methods when f of x is equal to x into f of x, and this f of x is equal to cos x or sin x, and if f of x is equal to tan x or secant x or log x. And one more method is if f of x is equal to polynomial in x, and the other is Euler Cashy differential equations. And here for this method I will give you a trick for finding the solution. So we will learn one after other. So we have totally 7 methods to find a solution for homogeneous, higher order homogeneous linear differential equations. So we will learn today these methods, 4th, 5th and 6th, 7th methods. And the 4th one, f of x is equal to, if f of x is equal to x into f of x, and this f of x is equal to cos x or sin x, we have the equation of the form of f of d into y equals to f of x. Then you just take y is equal to 1 by f of d into f of x. You just remember this formula. Actually this is a formula for finding the solution for higher order non-homogeneous linear differential equations, and the formula is y equals to x into 1 by f of d into f of x minus f dash of d by f of d all square into f of x. Here f of d is nothing but auxiliary equations for the given equation. Let's take one example. D square y by dx square minus 2 into dy by dx plus y is equal to x into sin x. See, look at it. RHS. Here we have x into f of x. F of x is sin x. You just take the formula and you just substitute f of d. What is f of d here? This is d square minus 2d plus 1. This is f of d. You just substitute here d square minus 2d plus 1 into f of x is sin x minus f dash of d. You just differentiate this one, 2d minus 2 is f dash of d. Substitute in here whole square, f of x is sin x. And from here we just do as a previous methods. You just substitute d square with minus a square. What is a square here? Here we have sin ax, where a is 1. So substitute in the place of a with 1. So we have minus a square is minus 1. Now y equals to x into, substitute d square with minus 1. Minus 1 whole square, d square is minus 1 minus 2d plus 1 into sin x minus 2d minus 2 by d square is substituted with minus 1 minus 2d plus 1 into sin x. Now here we have 2d in the in the denominator. We need d square to substitute -1, so just I multiplied and divided with d. Okay, now x into differentiation of sin x is cos x minus 2 into d square is, here d square is -1, minus, again you just look after this, we have for d square, you just directly substitute -1 in the place of d square and just simplify. From this we will find particular integral for this type of methods. When RHS is having x into f of x, you just use this formula for finding the solution. So total solution will be equal to particular integral plus complementary function. One more method, if f of x is equal to tan x or secant x or log x, this is nothing but equals to r. R is nothing but f of x is a function of x. See, you have to remember this formula for finding solution. Here particular integral is equal to minus y1 into integral of y2 into r by w dx plus y2 into integral y1 r by w into dx. Here r is tan x or secant x or log x, and where w is Wronskian, and y1 and y2 are the solutions of complementary function. For y1 and y2 you have to find a complementary function. From there you will have y1 and y2 are nothing but solutions. Now where w is Wronskian, how to find a Wronskian? You just need to find a determinant for these solutions. See, Wronskian is equal to determinant of y1 y2 y1 dash y2 dash. If you have y3 here, next y3 dash and y1 double dash y2 double dash y3 double dash, you have to take this to find a Wronskian or to find a determinant. You may know to find a determinant. I hope for finding a determinant, first the matrix should be 2 by 2 or 3 by 3 or 4 by 4, nothing but a square matrix. For a square matrix you can find a determinant easily. Now I will explain one example for understanding purpose. Take a problem, solve d square y by dx square plus a square into y is secant ax. Now write the auxiliary equation, d square plus a square is equal to 0. From here we have d is equal to plus or minus I into a. You know this is equal to d equals to 0 plus or minus I a. This is equal to a, this is equal to b. This is of the form of d equals to a plus or minus ib. For this type of solutions, we have complementary function is equal to e power ax into c1 cos bx plus c2 sin bx. I had explained this in our previous classes. Now from this we can write the complementary function is equal to e power ax, where a is 0, e power 0 is 1 into c1 cos b is, here we have b a cos ax plus c2 sin ax. So from here you can find y1 and y2, the solutions of a complementary function. y1 is equal to cos ax and y2 is equal to sin ax. Now using y1 and y2 you can find the Wronskian, where Wronskian is equal to determinant of y1 y2 y1 dash and y2 dash, which is equal to, where y1 is cos ax, y2 is sin ax. y1 dash differentiation of cos ax is minus a into sin ax, differentiation of sin ax is a cos ax. Now you just find the determinant for this. Determinant is equal to a. See, I am going a little bit fast for completing of syllabus, as we have exam in December itself, that is CSIR exam, and one more thing is GATE exam in February. So we have to cover the overall syllabus of physics. You just do few more examples for practicing purpose. Practice, as we know, practice makes man perfect. So please solve more and more number of problems for a method. You will find number of problems in textbooks, or from online you can collect them. Now we will solve this using a formula. As we know, formula is y equal to minus y1 integral y2 r by w into dx plus y2 integral y1 r by Wronskian into dx. Now substitute here. Substitute y1, y2, w and r values. We have y is equal to minus y1 is cos ax integral y2 is sin ax into, what is r here? In our problem, this is r. Secant ax is r. You just substitute here. Secant ax by Wronskian is a into dx plus y2 is sin ax integral y1 is cos ax, where r is secant ax by a into dx. See, as we know, secant ax is 1 by cos ax. Substitute here. Sin ax by cos ax is tan ax dx plus sin ax by a. I have taken a outside of the integral as a is constant. Now cos ax by sorry, please correct this one. As secant ax is nothing but 1 by cos ax, we have cos ax by cos ax get cancelled. Now we have left with a. So here we have 1. Now integration of 1 dx is x. You just please correct this one. And integration of tan ax minus of log mod cos x. This is the particular integral. You just practice more and more problems so that you can do easily, and you will do problems in fraction of seconds or fraction of minutes. It is very much useful for doing problems in exams as fast as possible. Now we will go with method 6. If we have f of x is a polynomial in x, then I hope you have learnt this method in your lower sections itself, in your school itself. This is a very simple method. You may not find this method in your textbooks. For finding solution for this type of problems, you have to use a binomial theorem. Without using of binomial theorem, I am giving a trick to solve this type of problems. So we have a particular integral is equal to f of x by f of d. See, f of d from lower to higher powers. You just remember this one, f of x from higher to lower powers. We will solve a problem so that you will understand easily. Now particular integral for this is equal to 2x plus x square by, this is d square plus 2d plus 1 by common. Okay, this is an auxiliary equation which is equal to 0. If you take equal to 0, then this will be an auxiliary equation for this problem. Now f of d, what is f of d? We have here d square plus 2d plus 1. This must be taken from lower to high powers. So 1 plus 2d plus d square. Okay, I hope you understood this. And from here f of x from higher to lower powers, we have this one, x square plus 2x. Okay, now draw a line. I will explain this problem in a fresh page so that you will learn or you will understand easily. Look at here carefully. So we have x square here, we have 1. To get here x square, I am multiplying with x square. So now we have 1 into x square is x square plus 2 into differentiation of x square is 2x plus twice differentiation of x square is we have x, 2. 2x is differentiation of 2x is 2. We have x square plus 4x plus 2. Now write this x square plus 4x plus 2 here. I have multiplied with x square, so I have taken x square here. So please try to understand this one. Minus 4x plus 2x is minus 2x minus 2. Now take again 1 plus 2d plus d square. Okay, now we have here minus 2x, here we have plus 1, so I have taken minus 2x here. Now multiply with minus 2x. 1 into minus 2x is minus 2x plus 2 into differentiation of minus 2x is minus 2, and twice differentiation of minus 2x will be 0. Now we have minus 2x minus 4 right here, minus 2x minus 4. Now plus this will get cancelled, we have plus 2. Now I have taken 1 plus 2d plus d square again. To get plus 2, I am multiplying with plus 2, so I have taken plus 2 here. What we left with 1 2 is 2 plus 2 2 is 4, and the differentiation of some constant will be 0. We have 2 here, so write 2. This is the remainder. Now the solution will be particular integral is equals to x square minus 2x plus 2. This is the solution for given problem. We have left with one more method, Euler Cashy non-homogeneous differential equation. The equation will be of the form of x power n into d power n y by dx power n plus k1 x power n minus 1 d power n minus 1 into y by dx power n minus 1 plus and so on plus x n minus 1 into x dy by dx plus kn into y is equal to f of x. Here k1, kn minus 1, k2, kn all are constants. For solving these type of equations, for getting a solution for these type of equations, we have to take x is equal to e power z. As we know, when exponential is come to this side or multiplying with log on both sides, we get log x is equal to z. Log and the exponential get cancelled, we left with z. Now differentiate this equation, log x plus z. Now differentiate this equation. We have differentiation of log x is 1 by x into dx, which is equal to differentiation of z is dz. Now dz by dx is equal to 1 by x. We have to replace x with e power z, and we have to proceed. I will give you one example. Before that, we have to replace here x into d by dx equals to d. Here take x into d by dx as d in this equation, and x square into d square by dx square equal to d into d minus 1. X cube into d cube by dx cube is equal to d into d minus 1 into d minus 2. You just replace these terms, because always writing x power n d power n by n into y by dx power n and d power n minus 1 by dx power n minus 1 is little bit typical. So just first of all you just replace all the differentiation terms with d's, where d is nothing but a operator. Take an example. Solve x square d square y by dx square minus x into dy by dx plus y equals to log z. Now you just take x equals to e power z. X is equal to e power z, and this z is equal to log x. Okay. Now particular integral is equals to 1 by f of d. What is f of d here? You just look this one. To find a complementary function, we will write first of all auxiliary equation. For this equation, auxiliary equation is d square minus d into d minus 1 minus d plus 1. How we get this one? First of all, you have to replace x into d by dx with d. Okay, x into d by dx with d, and x square into d square x by dx square with d into d minus 1, so that we will have a auxiliary equation of the form. Now you just substitute here this f of d here. Okay, don't get confused. Here I did complementary function, and here I did the particular integral. Okay, now f of d into z. What is z? Here z is log x. Okay, now which is equal to 1 by what is f of d? D minus 1 whole square into z, which is equal to d minus 1 whole power minus 2 into z. Now find using binomial theorem. You just expand this one. 1 d minus 1 whole power minus 2 is 1 plus 2d plus 3d square plus 4d cube plus and so on into z. I'm just neglecting higher order terms. Now we have 1 into z is z plus 2d into z is 2dz. What is d here? X into d by dx. This d is x into d by dx, where z is log x. Z is log x plus 2 into d into z is log x. Now x into differentiation of log x is 1 by x. We have left with log x plus 2, and this is a complementary function. So using x into d by dx is equals to d, and x square d square by dx square equals to d into d minus 1, we will find the auxiliary equation, and from here we will find the roots, that is d equals to 1 comma 1. Here, as we have d minus 1 whole square, from here we can find d is equals to 1 and 1, where these are real and equal. m1 is equals to m2, and the complementary function will be equal to c1 plus c2 into z e power z. Okay, before problems we have taken here x. Okay, but here we have log x is we have considered log x as z. We should take here z. Okay, and now the total complete solution will be equal to particular integral plus complementary function. You just solve these homework problems. Okay, now don't forget to subscribe to my channel Quantum Academy for Physics. In further classes we will learn about the complex analysis, and then after matrices, and partial differential equations, Laplace and Fourier transformations. We will go one after other. Please subscribe to my channel Quantum Academy for Physics, and click on the bell icon for further notifications. I hope that I will upload at least 3 videos a week, and thank you for watching.